In this video, we're going to talk a little bit about what the computational and data sciences actually are. So I think the best place to start is first by asking, what is science? And I like this quote that I found recently from a physicist called Brian Keating, who said, "We like to imagine science advancing through brilliant ideas, whiteboards, coffee, a genius squinting heroically. In practice, science advances through better instruments and the slow, slightly humiliating realization that our previous ideas were incomplete or wrong, often wrong." I think that we often get a picture of science from the media um, that celebrates individuals um, uh, and gives the impression of sudden breakthroughs. But as this quote points out, it's really a sort of gradual, incremental advance. Often breakthroughs come on the back of a long, gradual journey, um, and and there's often a lot of wrong turns along the way. The key idea, really, in science is that a scientific idea is one that must be disprovable. Okay, if you have an idea about how the world works that could never be disproved, then that cannot be a scientific idea. And so we have this idea of the scientific method, which no one can really agree exactly what it is, but in general, most uh, descriptions of it say that you have hypotheses, right? Scientific hypotheses, ideas about how the world works, that are disprovable, and then you do some sort of experiment to try and disprove that hypothesis. And either um, your experiment finds evidence that supports the hypothesis, in which case, great, right? You can try and do another experiment in a different way to disprove it, or the experiment does find evidence that contradicts the hypothesis, in which case you kind of have to go back to the start again and revise your hypothesis uh, to account for this new evidence. So computational and data sciences fit as sort of two sides of the same coin within this picture. So we talked before about how computational science involves a lot of simulation and actual doing of experiments, right? So it's a way to go from our theories or hypotheses to actually doing an experiment on a computer and generating some data. Then once we have the data from an experiment, either a computational experiment or an experiment where we've collected data out in the real world, we can use data science to analyze that data and draw conclusions and then go back and reflect on our hypothesis and possibly update our theory. So there are two Venn diagrams on this slide. The one on the left shows how computational science is essentially a hodgepodge of ideas from mathematics up here in blue, sort of applied mathematical methods. Also computer science, which is about the theory of how computers work, and computational science takes some of that theory and actually applies it to a particular scientific discipline. Similarly, data science also takes ideas from mathematics up here, right, particularly from statistics and visualization for analyzing data, as well as techniques from computer science around managing data and using data to make predictions. And then again, applies that to a particular scientific discipline and a particular experimental data.